So I think it's time to start. So welcome everybody to the Lisp working group session. I'm Luigi. Online we have Joel. We are the co-chairs of this working group. There is also Padma, our secretary, that will help taking notes. Online you have the note well, which you read during the registration procedure. My video is just to say hello everybody, and now I stop to save some bandwidth. Okay. The usual pointers, if you are connected, you are aware of them, I guess. And just to go quickly through our agenda, this is the last time we met, the situation in 109, okay? And this is about today, so we don't have any red dots anymore. The BIS documents are in the RFC editor queue. What we have now is Lisp security. The Shepherd's review has been done. The Shepherd and contacted the authors for basically editorial correction that needs to be done, and this will go soon through the pipe. We have the Nexagon document as well. He's waiting for the write-up. I plan to do it next week so that we can push that forward as well. I think we are pretty close with the Young model document, but yeah, we will move it forward after this meeting, okay? And there are a few drafts, working group drafts, that need to be moved forward. I guess we will come back a little bit later on the last presentation on this point. In the last couple of years, obviously, we put a lot of effort on the BIS documents. Now it's time to look at what is still in the data tracker as a working group item, and see what is the interest from the working group and what should be done in order to move this item forward, or drop them if there is not interest anymore from the group. So what we plan to do is, between this meeting and then 112, is to ping on the mailing list on the specific documents in order to check what the group wants to do with each and every document, okay? This is the agenda today. Okay, so we have our first presentation about PIM. This is a document actually that is which is part of the PIM working group. Okay, but it's good to have an idea what is going on there. So Stig should present it to us. And I see Stig is online. Very good. Then we have a Lisp transport for policy distribution. Michael will going to present it. Lisp fix. Finally, an update on Uberlay, even if we don't have a document yet. And Mark wants to present a little bit the open items that are in Lisp from the perspective of commercial implementation. Does anybody have anything to say about the agenda? Anybody wants to do like last minute or second? I see in the chat Fabio asking, LispSec is blocking the BIS document, or they will proceed in parallel. As far as I remember, the LispSec is blocking only the console plane document directly, but because the two BIS documents are interdependent, they basically are both blocked. So as soon as we have the LispSec push it forward, and when it passes the IETF review, blah, blah, until the RFC, then goes to the RFC editor, then everything is unblocked, okay? And unless there is a specific necessity, I will run the slides for everybody so that we gain time on that side, okay? Okay, so no further comments. So I guess I put on the slides of Stig so that we can move forward Oh no, the presentation.
Yeah, hi, this is Stig here. I have like an audio issue. I'm not able to listen at the same time as I'm talking. It's kind of half duplex. So I'll start presenting and then I'll pause occasionally to check if there are any comments. Does that sound okay?
Yeah, sure. I just need to put it on the red screen. I don't know why it doesn't want to go. Here we go.
Check with me afterwards. There's a way we can simplify this, but we
Yeah,
won't change.
Can you guys see the screen right?
The draft that has been presented in the PIM working group, but it's also Lisp related, so it would be good to discuss it here. So yeah, if you go to next slide. So there is like this RFC 8059 that describes how to do multicast with Lisp. So one way is to use signal-free multicast, but this solution is based on sending PIM joins kind of over the top between the XTRs. So there was a draft that was done before. Forget the RFC. Actually, that is 8059. That was done in the PIM working group, but it was also discussed here in Lisp. And when we made it an RFC, yeah, it was basically last called in both working groups and so on, but it was a product of the PIM working group. There is a limitation in that draft that we want to solve. And yeah, likewise, like with the previous draft and RFC, we would like to discuss it in both PIM and Lisp. And we want to make sure that it makes sense from this perspective, but we also want to make sure that it's correct from PIM perspective. So from PIM perspective, it's more about the exact encoding and stuff, while Lisp is, I feel like it's more the use case. Any comments so far? So for head-end replication, we have this solution where we can specify, send a join over the top from like ETR to ITR and say, we want this particular S, G or G encapsulated and sent to this destination RLOC. So basically the ITR, like the yeah, in the source site, can replicate and send packets to each of the destination RLOCs that need to get the packets. However, when we do Lisp when we do multicast in the underlay, you would like to encapsulate and send packets to a certain underlay group. And there's no solution for that right now. Currently, in implementations, I know it's just basically hard-coded, or you have to configure it on the ingress what groups to use. What we would like with this new draft is to have the receiver XTRs, like the ETRs, specify which group to use for the encap. So that is the goal of this. And then there was some question, can we reuse the existing RLOC attribute in 8059 and then code the group address? Or do we need to do a new, create like a completely new attribute for this purpose? All right, I'll pause again. Let me know if any questions. Continue. Sorry about this audio issue.
I guess you can move forward. If there is anything that people ask, they can raise their hand and we will manage the question. Okay? Does it work for you?
Yeah, can we do the next slide, please? Okay, great. So, so as I was saying, there's no way today for the receiver ETRs to specify what group they would like to be used for the end cap. So that's what we want to solve here. We have some use cases where we might want, say, for various reasons, you might want a particular group to be encapsulated in different groups in the core. So like if you have an S, G in the like a multicast source, you might want to encapsulate that into 2 different group addresses when it goes through the core. So basically, replicate and have like 2 copies of the packet with each with a different encapsulation. Or there could be cases where we also want to say that, so in many implementations I know, it's kind of hard coded that if you have a certain group in the, for the multicast source and the source side, you want to encapsulate that into a specific group in the underlay. But you would like to have the freedom to say, maybe even for the same group, 2 different sources, you might want to encapsulate them differently in the core. It might be because the band diffused, for instance. But the key thing is we want the flexibility where the receiver ETR can signal this group address. That's what it's all about. Slide. Yeah, more or less skip this, but this is what it looks like. You have like multiple Lisp sites, and you have like the source in one site, and then you might have multiple receiver sites, and each of the XTRs, like the border routers here, might want to specify different group addresses they want to join. Next slide, please. So just to go into the exact details, the RFC 8059 defines what we call a PIM join attribute, and it's formatted like we see on the diagram here. And what we are proposing in this draft is to keep the exact same format. The only thing is that the receiver RLOC can be a multicast group address when you do multicast in the underlay. So it's not changing any format, it's just like relaxing what can you put in that receiver RLOC field. So we've been looking at existing implementations, and we think this should be fine. So today, implementations that do multicast replication, multicast in the underlay, they don't look at this RLOC attribute at all. While implementations that would support like this new extension, they would basically start checking what group address to use by checking this attribute. So the main thing is we want a minimal change, but of course the priority is not to break any existing implementations, but we think that is fine. So my question for the Lisp working group is really, are you okay with us moving on with this in PIM and adopting it in PIM? Any concerns from the Lisp side? We can of course keep you updated on any further changes if there's any, and also when there's a last call, we can do that in the Lisp work group as well. All right, any questions, comments?
Any question? Richard? Richard, you are in the queue. You want to speak up?
You need to unmute yourself if you want us to hear you. The system thinks you're requesting to present.
Can you hear me now?
Yes.
Now we can hear you.
Oh, okay. Okay. Sorry about that. I click the long button. So do you allow Lisp node and non-Lisp node to join PIM distribution tree at the same time? So yeah, so maybe you have already like described it in our draft. I just like to know. So
we do allow that, or I would say there's no easy way to prevent that. So in theory, yeah, any router could or host could join that group and possibly receive the traffic. Of course, it's Lisp encapsulated, and they may not know what to do with it. So ideally, you should have some fixed group addresses in the underlay that is, only used for this purpose, and ideally only Lisp routers to join. But yeah, it cannot really be prevented.
Okay. So thank you very much, Stig. I think there are no problems in moving this item forward in your working group, in the PIM working group. Just keep us posted on the progress.
Yeah, I might say, we might also look into how we can do this better with signal-free multicasts in the future. But yeah, thanks.
Okay. And now we go to Lisp transport for policy distribution. And here we go.
Awesome. Hey, Luigi, you can hear me, correct? Yeah. All right. Cool. Yeah. So Mark
Yes,
and I
yes.
are actually Mark and I are going to co-present. We just have a few slides, so maybe save the questions for the end, so that way Mark doesn't get messed up in the queue for speaking. So yeah, thanks, Luigi. This is Lisp transfer for policy distribution. We're going to talk about the motivation, proposed encoding, and Mark will describe some of the process for distributing this policy. So next slide. So the motivation actually was born out of a discussion or discussions with multiple Lisp operators. Two in particular. The one on the left is a Lisp operator who's more like a service provider, providing internet connectivity to n number of customers, and their internet edge routers are actually running Lisp. There's another there's another use case that was born out of a discussion with an operator who's managing a private WAN. So there's multiple remote sites that are connected over commodity internet back to a hub site. And in both cases, oddly enough, at the same time, they both had asked that if we're using the Lisp architecture to return RLOCs for these ITRs to use, could we also return other bits of information to these ITRs? So that's kind of a broad request, and when we got down to it, we found that they were really asking for things like simple policy stuff like QoS or some access control lists. For example, in this internet edge use case, we found that numerous customers that were using of the service provider were connected to their transport using subline rate speeds, and they had no QoS configured. Similarly, with this private WAN use case, they also wanted some basic security ACLs pushed out. So they were asking, well, if our needs for distributing things are somewhat lightweight, could we reuse the Lisp architecture, because it would give us an advantage. We can keep everything kind of in one architecture. We don't have to invest in any other areas to push simple things out. So next slide. So in order to do that, this is pretty much the encoding that we're proposing here. It's using this Lisp naming convention, where as an EID key to look up in the mapping system. This is an example. This is policy-CE-RTR01. and that lookup returns a locator that's using this JSON LCAF. In here we're encoding it as a string. So what happens here is, if you can imagine this customer connected to that Lisp service provider, they would register, have basic information configured on this ITR, where they can communicate with the map server, and after they register, they would basically also receive a policy that would be programmed on that RLOC. And here it's basically, all right, we're going to do some subline rate shaping, so it's pretty elementary. So how we do that? Next slide. Mark is going to describe that.
Hi, can you hear me? Okay.
Hear you. Go ahead.
Yes. Okay.
Yes. You can hear you.
So in terms of packet flow that is proposed in this draft, when investigating this issue and testing it, we realized that this is a perfect match with the PubSub specification that it's about to go out, right? And so yeah, in very simple terms, or trying to illustrate the idea, we have this figure where you would have a mapping system and multiple routers that are coming up. In terms of how to specify the policy, the draft assumes that particular policies are either directly configured on the mapping system, or you could have a controller that uses the map registration interface to onboard these policies on the mapping system. And the next step is just that when the routers come up, they would have this procedure by which they send a map request to the mapping system, asking for a specific known string, right? In this example, policy RTR01, saying, okay, can you give me the policies that apply to me? This map request is sent with the n-bit set, so that the mapping system registers this as a subscription. And well, as you well know, as a response to the subscription, mapping system will send the map notify with the EIB and the corresponding policy in JSON format. If you could go to the next slide. And why PubSub is a perfect match is because then with the subscription system, any change in the policy registration on the mapping system would just be published, right, through an additional map notify with the updated JSON to the RTR that has, to the router that has subscribed to this policy. Yeah, in this particular example, the rate in these simple policies changed, and the mapping system just publishes this, right, sends the map notify to the XDR. Next slide, please. So that's it, right? We're exploring what are the next steps for this draft. One important thing here is EIVs are specified as distinguished names. There's an ongoing debate around these drafts, and it would be important for this specification to go forward that at least distinguished names are accepted as a working group item. And we are especially looking for feedback and comments on the draft. What do you think about the use case? Do you think it fits well the objectives of the Lisp protocol and the working group? And I think, yeah, that's it.
Okay, I put myself in the queue, so I'm first. I was hoping to hear some explanation from you as to whether you are assuming this is a dedicated Lisp system where the Lisp mapping system is only being used for this purpose, or whether these are actually distinguished names, and if they're actually distinguished names, what is the mechanism to make the policy names distinguished?
Yeah, hey, Joel, great question. I think in this use case, the semantic of distinguished in most cases may not apply, and let me explain. Assume that you have a deployment like I was showing in the motivation slide, where you have 100 Lisp sites and 50 of them all connect or using circuits of like 200 meg. So instead of creating 50 different names to identify those 50 different ITRs, what the operators would probably want is something like, just give me a single name, and I'm going to use that single name for like 50 of those ITRs because they all require the same policy. So
that works, but that's not actually the question I asked you. The issue is, if this is a Lisp system that's being used for other things and that has Lisp distinguished name lookups for other purposes, and Dino has outlined other purposes, we have to keep the names separate. And yeah, the other purpose seems to produce names that are likely to be different until there's yet another purpose and yet another purpose, and then that's why they're, in the other context, they're called distinguished names. And there doesn't seem to be any mechanism here to keep it distinguished. I suggest you think about it and comment on the list. I won't insist on comment here. The other thing I would like you to deal with on list and in the draft, but don't try to answer today, is to spell out the relationship between these policies and PCE-driven policies and SR policies and BGP-based policies. We're developing a lot of policy mechanisms. We need to know how they're going to work together, or if they're not, well, okay, but we need to know.
Fair enough, thank you.
Good one. Yeah.
That's a good point, Joel.
Dino?
But let me respond to Joel's question first. The question was, can it use the same Lisp system or the same mapping system? Of course, if it uses the same mapping system in different instance IDs, and the instance ID for the policy-based stuff is used only for that, then there's no name conflict. Of course, if it's registering to an instance ID that's using names for other things, then obviously the names have to be unique. So I agree with that. Another question, guys, can you go back to the slide where the map notify was? If you can do that. Okay, if you can't do that, I'll start the question while you're trying to do it. So guys, I'm not sure we put this in the draft, but we might have an MTU problem with the map notify if the JSON is really large. The JSON's great because it's supported by so many different types of systems and APIs, but depending on what the names are, it can be rather lengthy. I have a lot of experience with JSON and found out that I ran into MTU problems right away. So I think we should just say in the draft that the map notify may be fragmented. And I think we should not say that the JSON could be sent in multiple pieces in different map notifies, because that will generate map notify acts. So I would say let's use fragmentation, where the map notify is sent once by the Lisp module, IP fragments it, it gets reassembled on RTR01, and then when it gets reassembled, Lisp is presented with a large datagram so we can map notify that act that. Now it turns out that the map notify act, I believe, has the same RLOC record in it, so it may have the same problem with MTU. So I think we should have a look at that and update the spec. Comments?
No, that's a good point. Yeah, it was an oversight. We didn't address this one, but yeah, thanks for this.
Mark, I mean, if you think it's going to be simple and relatively small like this, that's fine. But I think you might want it to be extensible. I think you have plans to make it extensible in the future. So.
Yeah. Okay. Yeah, let us investigate.
I didn't even think about the MTU. Ironically, every single problem I've run into in deploying Lisp early on was related to MTU, so it escaped me. It must have been too obvious to pay attention to. Thank you.
Okay, we
What
are
was the
running a
chat?
little bit late. Maybe we can take it
We can take
either
it offline.
offline or to the list. Victor, is something really important you want to say? I see you.
We can take it on the list. It's okay.
Thank you very much.
Thank you very much,
Victor.
Victor.
No problem.
So it's now Sharon, and I slide.
Just want to say hi. Good to see you guys. Thank you that it's not 3 a.m. All right. So the Lisp fix is about in-network analysis of flow information. So it might ordinarily belong to the IPFix working group, but it has more to do with computing network or compute first networking or contextual networking, which is an area that I know Luigi had a buff on, and it was in CoinRG, and something I'm very interested in. And if there is interest, we will see if it's possible to pursue it on the list. So next slide. All right, so all these protocols, IPFix, NetFlow, SFlow, FlowLogs, they're basically gathering stats about packets that share a characteristic, a flow, and aggregate based on some time slots or volume loss slots, and from an exporter to a collector. Next slide, please. So in principle, there is a flexible aggregation architecture specified in IPFix. In practice, though, it's very ops administration type aggregation, where collecting stats is either used for long-term collection using aggregation, administrative aggregation, or for debug, just checking if what's wrong about a specific flow or a conversation in a network. Next slide, please. What we want to do is introduce a list-based aggregation to IPFix and like protocols, because that type of aggregation is able to unlock new possibilities of how to use these existing mechanisms, which are very popular, in addressing new challenges. Next slide, please. Okay, so what's new? What's new is in the cyber world, as you can hear look in Wall Street Journal every other day, the attacks are very sophisticated. They penetrate using any application layer to some random device and end device, but then start lateral movement. And the lateral movement builds up a DOS attack, a SQL attack, an SSH attack, a port scan, leaking information or preparing for ransomware. So the attacks are digging in. It's not like something which is a one shot, one place. On the other hand, the new capabilities are that with AI, it is now possible in real time to recognize normalized patterns of applications and see if there's lateral movement hiding behind it. So there's a very nice paper I can send to you if you're interested. But after normalization, neural networks that were trained on completely different organizations are able to detect non-kosher patterns of, let's say, backup or CRM or whatever application pretends to run there, and see lateral movement behind it. Another thing which is a new challenge is that traffic from anywhere to anywhere group can show up on any layer 3 port because of virtualization, VPNs, VLANs, and so forth. And that makes it very hard to track who is talking to who in a specific application context. On the other hand, the same technologies that allow for virtualization are also able to steer the sampling to different buckets and therefore to collect differently, even though a subnet is now scattered all over the network, it's able to collect samples per subnet or per work group very effectively. Last thing is distribution. Applications are, especially cloud native, are very distributed. There is a lot of east-west traffic for every north-south request. And that creates a huge load and virtually impossible to put probes in that data path. On the other hand, we know how to distribute, and therefore we can also distribute the analysis logic better than we used to. So we don't have to concentrate the logic in order to analyze information. And with the Lisp approach, this can help us battle that challenge of high volume. Next slide, please. Okay, so what is the idea? Exporters, instead of sending to a collector, they can use a mask, an EID mask, or even maybe a Bloom filter. The point is to associate a given family of flows with an EID. And therefore, we are sending these samples to a collector, which is also an analyzer, which can detect anomalies at real time. This is not an administrative approach. This is sort of in-network protection. Therefore, we don't concentrate the logic or the sampling traffic, which may be very, very heavy just to aggregate samples. Next slide, please. What's the value of this approach? Basically, instead of putting probes where we can't put probes, for example, in spines or cores, or it's very hard to put probes like in highly regulated industries such as hospitals and utilities, and enterprises don't have anywhere to put probes because it's 5G LAN. It's all they don't have any access to the line. We can now put these probeless probes on a tangent network, which will scale just like inline, but without being inline. The algorithms themselves have been tested and are tested in about 100 installations. What's not yet mainstream is this sort of net native aggregation that can be applied. Next slide, please. So what do we propose is it's a use case of leveraging Lisp for computing network, and just like the other cases where we leverage Lisp for that, we leverage the EID, the logicalness of that we can just define EIDs as compute contexts algorithmically or with rules, and signal free, which is once there is a computation, you can subscribe to its results and therefore distribute the entire logic without concentrating. So per flow, we'll have to define how you set up rules, and that can apply to IPFix or flow logs or any of these. And then per collector analyzer, we'll have to specify subscription for things like SSH attack, DDoS HTTP, things like that, injections, SQL injections, and so forth. So to know whether to block that flow right away if it's detected. And that's it, basically. Next slide, please. If I have 2 minutes, I'd just like to give you and if people are okay with proceeding with this, let's take it on the list, and I will specify the draft. If it's not the right place, then we can decide that too. I want to give you a quick summary of what's going on with this Hexagon, which is also a computing network draft. using the same principles, basically. Next slide, please.
Very quick.
Very quick, very quick. Sorry. Yeah, so it's basically having a very nice impact on industry, in the auto industry, specifically the AECC. And just to give you an idea of how computing network using Lisp is being used, it's used for realizing geolocation services, which is everything which is done in geospatial context. And that means, for example, queues for elements picked up from the road. So the queues can now be for picking up detections from vehicles traveling at 20 meters per second, can be 50 milliseconds away and not miss a bit. And these are AIDs. Multiple uploads can be corroborated, and then you can subscribe for events like hard stops or other detections. Again, that's an EID using signal free. So by that, basically the ACC accepts edge aggregation and push notifications and a lot of things which Lisp enables. So next slide, please. This is the last one, so, I promise. So basically my point is what enables this context switching while you drive to punt stuff to different queues without DNS resolutions and without worrying about what did you cache as a resolution if something changes, and what allows cars to keep on being subscribed to things and be identified as reliable sources, even though their modems may switch IPs, is Lisp. Lisp also allows for the service continuity while you switch IPs, allowing for point-to-point and point-to-multipoint signal-free over mobile and networks which don't support it. And also Lisp enables the geo-privacy while you're using geolocation services because of decoupling of the layer. The point is, it's very hard for the industry to connect the dots to Lisp without the Lisp hexagon type specification. So that's the value of these use case informational RFCs, is basically showing a specific vertical how to use Lisp for all these type of capabilities. So that's it.
Thank you, Sharon. If you don't mind, any question, we take it to the list because we are running really late and we have two more presentations to go. Thank you very much, Sharon. Interesting stuff. Here we go, Victor.
Okay, great. Can you hear me?
I even hear my echo.
Oh, let me lower the volume a little bit. Okay, that should be better, hopefully. Okay, so hello everyone. Let's quick get into this. We've been postponing the update on overlay for a while, and last time we spoke, there were a series of requirements that emerged in one of the deployment scenarios of the overlay, and the requirements are merely around the backbones and multi-AS backbones. So that's what I would like to focus on here. So if we go to the next slide, please, and maybe skip this and then go to the next slide. So it all started in our deployment of overlays at the International Civil Aviation Organization. They have a network which is built by multiple providers, and these networks provide different radio services for different reasons to the aircraft, but they do meet in that backbone. And they need a mechanism to actually peer in that backbone, and there's a series of peering agreements that are pretty stringent because of the nature of these organizations and because of the fact that they belong to different countries. In some cases, they are defense networks and so forth. So a series of interesting requirements came from that. So if we go to the next slide, please. This is a diagram of basically what's happening, very simplified, but a plane may connect to one or more radio regions at any given point in time, and each one of these communication service providers actually provide these radio services, and then they bring them onto an IP backbone. In that IP backbone, they will actually have BGP peerings, just like any service providers would, and they basically govern any connectivity or any prefixes that they may or may not service are governed by enforcing in those BGP peerings what is allowed and what is not allowed. So if we go to the next slide. In our environment, what we did, because we needed mobility and we needed multi-homing, we suggested the use of Lisp. And because of the regionalization of things, we suggested the use of the overlay. But it didn't matter how much you broke it down into site overlays, the net effect of it was that at the center, it was all meeting in the overlay, with basically that circle that you see in the middle. And as you can see, the underlay for that overlay portion of the network is basically where those peerings exist. So if we go to the next slide. So we end up basically with a federation of mapping systems, and that's where we left things last time we talked. So if we go to the next slide, I think we're going to get into what we really want to talk about, which is if I was to simplify this, whether it's in the context of an overlay or just in general, when I'm actually trying to deploy Lisp over a multi-AS backbone, what we end up with is a picture like the one that we see here. So in this environment, some of the requirements that were put forth are that each organization has its own AS, and in that AS, they must have both all the control of all the assets in the underlay, but also control of all the assets in the overlay, which meant basically assigning a map server to each one of these organizations. And the requirements go further in specifying that if an aircraft or an EAD was to be registered, it would have to be registered from the perspective of the XTR that it is connecting to. And that meant, for instance, if I am connecting to XTR-C, I would actually have to register to map server C. And if I moved to another AS and connect to an XTR in that AS, then I would actually register with the map server in that AS. So the EADs were being relocated. At the same time, we have now moved all the EAD information out of the underlay and into our Lisp mapping system. So the BGP peerings no longer have information to enforce any of the peering agreements of allowing or disallowing any of these prefixes. So that poses an interesting challenge, because the expectation is still that if a tunnel is carrying traffic for a particular prefix, that tunnel should not traverse an AS where that prefix is not allowed to be serviced. Okay, so if we go to the next slide. So these peering agreements refer to the EAD prefixes, that's the first thing, and they also specify terms of service. So cost of using the provider's network is one example. Level of service that will be provided, if it's preferential or best effort, and so forth. So there's an entire contract that is formed, and it does govern both the use of the overlay resources, but more importantly, all the infrastructure that is underneath, right? It's all about, are you using my bandwidth or not, and are you actually traversing my footprint or not? So there are two types of policies that are desirable in these environments. One type is transit policies, where basically it's the standard permission or denial of use of a backbone section for the purposes of transporting information to a particular EAD prefix. And the other type of policy is that which is effectively enforced at the ingress into the network, where from the perspective of an ingress AS, I may have multiple AS paths that I could follow to a particular destination, and I can evaluate what the terms are for those services, and based on those terms, determine which would be my preferred path for a particular connection. So that is the other policy that comes into play here and that we need to be able to enforce. If we go to the next slide. So if you look at the different scenarios that we had to cover, if I go from top to bottom in this slide, if from the perspective of a connection between ASA and ASB, which are the two ASs that are towards the center of the diagram, one of the scenarios is because of the policy defined, I would like to actually go through ASD and ASE. So I have two ASs to traverse before I can get to my destination. We would need a mechanism to enforce that and to evaluate the existence of that AS. Note that I'm not suggesting that there are any RTRs in the middle. So the aspirational goal is that we keep this as simple as possible for the operator, and not have to create explicit locator paths or anything like that. In any case, the four scenarios that you see there are, one is multi-AS, which is illustrated by the blue line. The other one is just direct back-to-back AS connectivity, which is that green line. And then we have a single AS traversal. And then there are also regions within the ASs. So I could have a service provider have an east region and a west region. And that is included for completeness. I don't know that it has many implications in us having to generate new machinery, but the reality is that you will have mapping servers assigned to each east-west of that region. So just something to keep in mind as we document requirements. So this is the interesting proposition here. How do we steer traffic through an underlay in a particular way? Based on information that we have in the overlay. Next slide, please. So this is an attempt at summarizing the requirements. So the scope is per AS. The AS is an underlay focused construct. Basically, it maps to the topology in the underlay. We would need to federate the different networks without any intermediaries. So there is no space for a broker of connectivity or signaling. They have to actually peer with each other. There's very little trust in these environments. So a third party, not welcome. And then, as we stated, the EID state is scoped per region or per AS. And we need to support those different types of connectivity. EIDs must move across ASs or have the ability to move across ASs and be multi-homed as well. And we want to enforce the policies derived from those peering agreements, ideally not require RTR. So if we go to the next slide, that's my last slide. My apologies to the work group for being so tardy with this. It's been a challenging year, to say the least, but there is a draft as of this morning, and I was, anyway, it's a long story, but there is a draft as of this morning. Where all of this is captured, hopefully in a structured enough way that we can initiate conversations. Step one, I've been discussing this with Dino and others. Step one is, let's see what we have on the truck right now and see if that fits the bill and we can actually address these requirements. And first stop would be DDT. So I think that's our next step, to actually put our heads to seeing if DDT actually will give us enough machinery to do what we need to do here. And if not, then there are alternative approaches to evaluate. That's it from my perspective. Hopefully this helps.
Thank you, Victor. And finally, we will have a document to discuss on.
We do. I'm sorry about that.
Dino, very quick, please.
It is real quick. On the second to last slide, you said there was a requirement for multi-homing. Did you mean multi-homing to different ASs?
Yeah, so the plane would connect to different radio networks, Dino, and the different radio networks may very well belong to different organizations, so they're on different ASs. I realize that complicates things, but that is a requirement. Anyway,
Okay.
we can talk more
Okay.
about it on the list, but there's been conversations around dedicating IP addresses to different interfaces so that doesn't become a multi-homing of an EID, but it just becomes a multi-homing of the host. But we can talk about that in more detail as we discuss the draft.
Thank you very much, Victor.
Thanks.
Mark, you're back on. Sorry, you don't have the full 15 minutes I promised to you.
No,
We can probably run a couple of minutes late, but not more, because anyway, Mitico will cut. Okay?
Okay.
Go on.
Let me go ahead and you stop me when we're done. Okay. At least we have a slide where we have the full list of drafts we want to talk about. And
Okay.
okay, so yeah, for this last presentation, what we wanted to do is basically list or compile a list of open items in the Lisp protocol that well, yeah, things that are still open but that are working in a commercial implementation of the protocol and are being shipped these days. And we wanted to see if we can recover the conversation on some of these items and yeah, promote it. Right? Yeah, presentation is we have a list of usual suspects here: Victor, Fabio, Balaji, Alberto, that helped compile this list. If you go to the next slide. Yeah, so motivation, as we are saying, these are items that have been discussed in the past, but we haven't had, well, for some of them, we haven't had much discussion lately. And what we wanted to do here is use this presentation to trigger discussions again in the working group so that we can progress on the development of some of these documents. As you will see, some of the documents are working group items, but some of them are not even working group items yet. And we want to see if we can move ahead with them because some of the implementations have been there for quite a while. Okay, next slide. So this is a short list of all the documents that we found, right? On the working group item bucket list, the two most important ones are EID mobility and Lisp VPNs. I'll go through them next. There are some other documents like vendor LCAF, PubSub, but these are already requested for publication. And if I understood well, Lisp Young model will also be in that list soon enough. So I'll skip talking about them today. And on the non-working group item list, there is one that is very important from this commercial implementation perspective, is the reliable transport draft. We had discussions in the past, quite intense, but we've parked this one for a while now, and we wanted to bring it back. Then we have the distinguished name discussion. This is a recent discussion, but we wanted to contribute at least explaining the use cases that well, how we have been using it. Overlay has been addressed by Victor just a moment ago, and then we have this NAT traversal and site external connectivity. If I have time, I'll give a short note in the end. Next slide, please. So with respect to Lisp VPNs and EID mobility, yeah, the most important thing about them is that they specify the basis of segmentation and mobility support that we use in all our Lisp commercial offerings. In particular, well, you guys know well these drafts. Lisp VPNs applies to the approach taken for L2 segmentation, L3 segmentation, as it describes the use of instance IDs, extended EIDs, and how to operate extranet. With respect to the mobility drafts, it also describes how mobility is architected, which mechanisms are we using, and also very important, different mobility approaches with different combinations of L2, L3, or how we use ARP and ND, or how we process ARP and ND messages. Yeah, these two drafts are kind of important, and we'll be working to promote them in the next meetings and also in the mailer. Just as a final note, both drafts apply to all areas of application where we have been shipping Lisp, right? Campus networks, data centers, IoT deployments, WAN, and even cloud extensions. Okay. Next slide, please. Yeah, just I'll go quickly through these two. This is just to state Lisp VPN's draft was last discussed in IETF 98, so when it was adopted by the working group. Updates, it hasn't had, it didn't have many updates since then, but one of them, for example, the latest one, Victor uploaded the draft, and we have updated how negative map replies are calculated when we have extranets in the picture. But we would like to highly encourage the group to read this draft and provide some feedback if to make it go forward. Next slide, please. And the same with the ID mobility. Last discussed in IETF 98 when it was adopted as a working group item. This one has really had small changes since then, and we had one outstanding item that we were still discussing, whether to include L2 multi-homing or not. But again, the same. If the working group could, or members here could read the draft and provide some feedback, this would help a lot moving this forward. Okay.
Mark, if you don't mind, we are 2 minutes late, and would be better maybe to stop right now. Okay.
Okay.
I think Joel agrees with me. We listened to your presentation, the list of drafts that you are interested in. Obviously,
Okay.
as I said at the beginning, for the working group items, we will move forward between now and 112. Okay. If we get to that, we will also start to look at the other draft that you mentioned. Okay.
I mean, just as a note, we are planning to, at least the ones that we've been driving, we are planning to restart also the conversation in the mailing list and to try to prepare some sessions for some presentations for the next session. Okay.
Okay. Cool. Okay. Good. I don't think we have time for a question from the audience. I just want to maybe there is something from Dino. Yes, he's suggesting to have next time 2 hours. Yes, we went back and forth on this. When we have 2 hours, then we have no many agenda items, and when we have 1 hour, we have too many. So next time, I guess we will go for 2 hours since we have a bunch of the document to discuss. Okay, awesome. So I can say thank you very much, everybody, for the presentation, for the question. We take it on the mailing list, and we will try to resume all the documents that were a little bit on hold for these documents. Okay, and join the last 2 days of the IETF online meeting. Okay, hopefully we can meet physically soon. Okay. So, yeah. Thank you very much, everybody.
Thank you.
Thank you. Thank you, Luigi and Joel and Padma.
Thanks, group. Bye.